Hey y'all, today we are going to find the slope on tables and graphs. So go ahead and hit pause if you want to have your paper set up like mine, and there are a lot of crazy lines down here. So hit pause at different points if you need to, and let's get started. Tips for finding slope on tables. So anytime you're looking at a table and they want you to find the slope or find the equation of the table, you're still going to have to find the slope before you find your equation. So, a tip for tables, I always tell my students, create loops. So, if you create little loops between your y values and your x values, you're going to be able to find your slope. So, we need to make sure that we remember what slope is. Our slope is going to be the change in y over the change in x. So as you create those loops, you're going to put the change in y over the change in x. Let's go ahead and do the first example of that. So going through, looking at our little loop-de-loos here, we're going to create them between each set of numbers. All right, so what happens to get from 6 to 4? Minus 2. What happens to get from 4 to 2? Minus 2. What happens to get from 2 to 0? Minus 2. What happens to get from 0 to negative 2? Minus 2. Now let's do our loop-de-loos for the left side. What happens from negative 1 to get to 0? Plus 1. What happens from 0 to get to 1? Plus 1. 1 to 2, plus 1. And 2 to get to 3, plus 1. So, slope is the change in y over the change in x. What was our change every single time? We were changing by subtracting 2. So, minus 2 over, what was our change in x? We were changing every single time by adding 1. So, slope is just that, the change in y over the change in x. So, m equals negative 2 for this example. Now, what if your question was asking for the actual linear equation of this table? Y equals negative 2x. Now, how are you going to get your plus or minus b? Your plus or minus b always shows up where your x is 0. Not where your y is 0, where your x is 0. So, plus 4. That's the equation for this table. Your slope is negative 2, but the equation is negative 2x plus 4. Let's look at the second table. So let's do some loop-de-loos first of all to see if we can figure out our slope before we figure out the actual rule. So loop-de-loos between every single thing. Loop-de-loos between every single thing. Now, what happens to get from 7 to 13? 8, 9, 10, 11, 12, 13, plus 6. What happens to get from 13 to 19? 14, 15, 16, 17, 18, 19, plus 6. 19 to get to 25. 20, 21, 22, 23, 24, 25, 26. I went to 26. It should have been to 25. 20, 21, 22, 23, 24, 25. I was thinking of the number 6, and I went up to 26. 25 to get to 31. 26, 27, 28, 29, 30, 31. So every time that added 6. Let's see what our change in our x is over here. 0 to get to 2, plus 2. 2 to get to 4, plus 2. 4 to get to 6, plus 2. And 6 to get to 8, plus 2. So the change in y, every single time we were adding 6. That was our change. So m equals 6 over, what was our change in x? 2. Can you simplify 6 over 2? Yes. So m equals 3. So if m is 3, that's our slope. If the question says, what is the slope of a table? It's 3. What if your question says, what's the full equation of this table? Y equals 3x. And is there a 0 value for your x? Yep. What's lined up with it? A 7. So plus 7. What if there is not a 0 value. Let's pretend that this example did not have this row. I don't know if I covered that up right on the camera. Yes, I did. What if it didn't have that row? So what you're going to have to do is use your change every single time that's happening as you're growing down. Do the opposite of that to grow backwards, to grow back up. Then you would have found what your 0 was. That's the easy way to do that. All right, so what if we need to find slope on a graph? So I went ahead and drew all of these lines on this graph. If you have graph paper, that'll be great. Go ahead and draw these lines if you can. If not, just keep up with me in solving for the slope, and then we will go ahead and write the full formula as well. So what is our tip for when we're graphing? So if I have a graph, I'm going to use, can y'all see that? Slope triangles. So slope triangles, you're going to go from lattice point to lattice point in order to find that slope. So let's start with the red line. I went ahead and put a little graph section over here to write our slope and our lines, our equation, excuse me. So let's look from lattice point to lattice point to lattice point to lattice point on that red line. So it is going up one, right one, up one, right one, up one, right one, up one, right one on the red line. So my slope of my red line, m equals 1. Because 1 over 1, 1 over 1, 1 over 1 is 1. What is my actual rule of this line? Y equals, well, 1x, because that's my slope. Remember, your b is always your initial value, your y-axis. That red line touched positive 2 on the y-axis, so plus 2. Let's look at the blue line. On our blue line, let's set up m equals and y equals. From lattice point to lattice point to lattice point, we're going to create growth triangles. How much did it go down? How much did it go over? Down 2, over 3. From lattice point to lattice point, this went down 2, over 3. From lattice point to lattice point, it went down 2, over 3. So our slope is going down, so negative 2 over 3. You've got to make sure you remember that anytime you were going down, it is a negative line. So y equals negative 2/3 x, and did that start anywhere? At positive 8, so plus 8. Let's look at the orange line. From lattice point to lattice point, what was happening? So it went up 1, 2, 3 over 1. That's my growth triangle. 1, 2, 3, right 1. 1, 2, 3, right 1. What is 3 over 1? 3. So my slope is 3. So y equals 3x. Where did that orange line touch the y-axis? Negative 6. So y equals 3x minus 6. Let's look at the green line. The green line is way down here. All right, I notice this is a negative line. It's going down from left to right. So looking at my lattice points from there to there, that's my growth triangle from lattice point to lattice point, and a lattice point is a point that is on a perfect intersection. This cannot be a lattice point. It's in the middle. A lattice point is on a perfect intersection. So you go from lattice point to lattice point on your slope triangles. How much down did it go? 1, 2, 3, 4. It went down 4. Right 1, 2, 3, 4, 5, 6. Right 6. So let's check that again. Does it continue to do that? 1, 2, 3, 4. Down 4. Right 1, 2, 3, 4, 5, 6. Down 4. Right 6. So what is negative 4 over 6? Can that be reduced? It should reduce to negative 2 over 3. So that means that we should have some lattice points in here that were not created, and that happens at times. You can have a smaller growth triangle. Down 2, right 3. Look at there. There was another lattice point. Down 2, right 3. So that simplified version, do y'all see how there are 2 triangles within this large triangle? That's how you know that it did simplify. So you always want to give your simplest form as your answer. So our slope, m equals negative 2/3. And our rule would be y equals negative 2/3 x. And where did this start? On the y-axis at negative 8. So minus 8. All right, and the very last one is this purpley pink looking line down here. Does it have a slope? No. 0 slope. So for that one, we would say 0 slope. But how would I write a rule for that? It's on the y-axis, and what number does it hit? 10. So y equals negative 10. Just like if you were to have had a line going up and down, undefined. Is there a slope? No, there's no slope because it is undefined. But we would have an equation. This is on the x-axis, so you say x equals, and what number does it touch on the x-axis? That's negative 6, so x equals negative 6. I hope this helps y'all. Have a great day.